Hi, and welcome to a brief tutorial about confidence intervals. In this video, I'm going to teach you how to find a sample size given a margin of error or given the confidence level, just kind of given some various pieces of information. But before we kick off, I want to draw your attention to confidence intervals and the concept of them in general, especially if this is one of your first videos. So if you've never played a game of horseshoe, the goal of the game is to aim at the stake. And notice in the picture, not all of the horseshoes are there, but they're pretty darn close. So I want you to think of the stake like the parameter. That is the actual number, the population value that you were looking for. It could be a population mean, it could be the population proportion, it could be anything that you want, but that is what you're aiming for. And every single one of those horseshoes is an interval. So here's the thing, your goal is to aim at the stake. Every interval, the job is to catch the parameter. The job is to get as close as you can. But here's the thing, you're not always going to make it. Maybe 95% of the shoes will, but not all of them. You're going to have some that get close, but just not quite. So here's the thing you need to remember. It doesn't matter on questions if they're like, oh, your data wasn't in my interval, so I'm wrong. No, that's not what matters. You're not aiming for the other horseshoes on the field. You're aiming for the stake. So don't panic if your data isn't inside someone else's. It doesn't mean that you're wrong, and it doesn't mean that they're right. The goal is the parameter. So with that in mind, keep in mind that any value is possible in the interval. It could be in the middle of the interval, it could be at the ends. The confidence interval is giving you a range of possible values for the parameter. Any one of those could be it. And again, 95 of those shoes will grab at the stake, and it's possible that 5 of them are going to miss because you're not always going to be right every single time. So I'm going to draw the curtain back, and take a look at finding sample sizes. Pause the video and try to answer this question on your own before pressing play. All right, welcome back. So we have a pollster is higher to look at the percentage of high school kids that are just in love with spicy food. If you live anywhere in the South, you know spicy food is very important to us, especially queso. I'm getting distracted. Anyway, 99% confidence within 2%. I need to know the sample that I need to talk to. So margin of error, again, is that plus or minus part of the formula when you build a confidence interval. So I need to be within 2%. So notice I changed it to 0.02. 99% confident means I have a 2.576 z-score. Notice I don't have the sample. And notice for the p-hat, it doesn't mention anywhere up in the question what the sample proportion is. So when this happens, the safest bet is to go with 50-50. What this is going to do is give you the highest possible sample size that will keep you within 2%. And then if the sample proportion comes back to be 40%, guess what? You already know the worst case scenario. You know the maximum amount of people. All right, divide by that z-score, square both sides, and do a little algebra. You never thought that'd come back to haunt you. Guess what it has? And again, don't tell me that you need 4,216.56 people. If you need 0.56 of a person, you're probably going to jail. At least you're going to get fired in the very least. So round up the nearest person, people. So 4,217 peoples. All right, let's try another one. Throw that one away. Pause the video and try to do this one on your own. Welcome back. So notice this one's a little different because I know the sample size, I know the margin of error, and I know that the sample proportion is 8% for unemployment. They want to know how much confidence did they use when they built this interval. So really be careful because again, that margin of error is 0.2%. So if you've got a very big number, that might have been where you messed up. I want you to focus on the right side of the z-score, that square root ugly crap that you have floating under. Keep in mind that is just a number. That is one of the trickiest parts of this problem is people want to square both sides and do all of this fun stuff, but it's just a number. So plug that part into your calculator, that whole square root part. Now it looks a little bit more familiar. Notice with z-scores, you do want to keep the decimal. And now your job is to find the percent confidence. But I only have a z-score. So you got to reach back and go all the way to second vars in your calculator, or if you have a z-table. Z-tables are very popular if you don't have a calculator. But this one is a calculator, so I'm going to use my TI-84. Notice when I put in the upper, I used 1.6, but notice the lower, I made it negative 1.6. Here's a quick visual to kind of help you see what I'm thinking. Confidence intervals are always that middle part. You have your number, you go up, and then you go down. So it's really weird when you try to find these. So I need to figure out a nice mirror to get me to where I need to go. So this one, you're dealing with 90% confidence. I know that seems a little bit weird. So please pause the video and try to rewatch if that was a little bit odd to you. Really try to digest that. Again, pause the video because this one is very important. Try to do this one on your own. All right, this one, first things first, I just want to know how large my sample size should be. So hopefully this one is like all the other problems we've seen. You got somewhere around 634 people. The second part says you want to reduce the margin of error in half. What should I do about my sample size? So I'm going to do this the long way. So I'm going to cut it down from 4% to 2%. I'm going to do all the math again. Ooh, notice it jumped up quite a bit. So what do you notice about the margin of error and the sample size if the level of confidence remains the same? So notice this one jumped up 4 times. So why was it 4 times? It says it reduced it in half. I wonder why the sample size just wouldn't be doubled. I want to talk to twice as many people to reduce the margin of error. Here's something to keep in track. Notice the sample is under the square root. Notice to free it, we had to square both sides. So if you end up squaring 2, you notice you get 4, and the sample is 4 times as large. That's where it comes from. So if somebody says, I want to reduce the margin of error by 1/3, what should I do about my sample size? You're just going to multiply it by 9, because again, 3 squared gives me 9. Same thing with maybe 1/4. I want to reduce it by 1/4. Your sample size will need to be 16 times as large. That's how all of those work. All right, crash that one away. This is our very last one. Pause the video, try to do this one on your own. Welcome back. So I'm going to just briefly show this. So notice you should need about 269 records. Pause the video to check your work, but I'm going to go ahead and move on. Because part B is asking us similarly, create a 90% interval. So I'm going to drop the interval down to 90%. Again, plug in everything you know, assume conditions have been verified, so that's why I can keep going. There's your margin. So somewhere between 40 to 47, again, interpret because it doesn't mean anything to anybody. You need to have an interpretation. 90% confident that the true proportion of women in the labor force in the US is somewhere between 0.4 and 0.47. So here's what I really want to get it down to. So again, you have that confidence interval up there in orange. I'm asking you, pause the video, try to answer all 3 of these questions before hitting play. They are tricky. Welcome back. So we have the probability of the true proportion is in the interval. What are the chances I caught the parameter? Most people here are going to say, well, 90%. There's a 90% chance. No, 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 no. That's not what the 90% means because guess what? This is a trick question. We do not know if we have the answer right or not. We don't know if we caught the parameter. We're hoping. We just know that 10% of the intervals are wrong. So when they say, well, what does the 90% actually mean? That means that 90% of all of the intervals made with a sample with that same size will capture the true percentage of women in the labor force. You can even say 90 intervals out of 100 will capture. Think of it again like horseshoe. Not all the horseshoes are going to aim at the stake, but maybe 95% of them will. That's what it deals with. It's talking about all the possible intervals. And again, should the labor force conclude that the percentage is actually lower than Europe's, which is at 46%? Well, I see 40% in my interval. So yeah, I can conclude that. Oh, no, no, no. Tap it, tap it, tap it, tap those brakes. Because notice 47% is also in the interval. And intervals are giving you all the possible values that it could be. It doesn't matter that 46% is at the high end of the interval. It doesn't matter that there are more numbers below 46 than above. What matters is that one of those values is correct, with 90% confidence. But it's possible that 47% are female. So I can't conclude that just yet. We got to be really cautious. All right, closing remarks. Pause the video, try to answer these 3 little points, and again, read the directions on the side. All right, if you increase your sample size, hopefully your confidence interval decreases. because if you're talking to more people, your interval is more accurate, you have less error. So with that said, if my margin of error jumps up, then the standard deviation is probably increasing. Your data has a lot more variation, therefore you have more error. So on here, the confidence interval increases, the sample size needs to blank in order to give you the same margin of error. Well, if I'm increasing the sample size, then I probably need to increase that. So if I need more confidence, I need to, again, be sure I talk to more people if I don't want to affect the margin of error. All right, pause the video, try these last three. Welcome back. So if the bound or allowable error, so think of it like the margin of error, increases, then your confidence level increases. Again, more error, bigger interval. As the confidence increases, your standard deviation remains the same. That's okay. If you're just increasing the confidence, you're just affecting the z-score. You're not changing the spread or the standard deviation. And the last one, as confidence level increases, your margin of error should also increase. You're more confident, therefore your margin is much larger because your z-score is getting large. I want to thank you for joining this video. Hopefully it wasn't too terribly long, and I hope I was able to guide you in your mathematical adventures. Please continue to watch any other videos on my channel. I appreciate you watching. Have a great day.